Let's look at our polynomial graph one more time. Just as a reminder, this is y equals x cubed minus 2x plus 4. I chose this graph again because it does a really nice job of showing what we would expect to see in a relative maximum and a relative minimum. It's pretty obvious that this point right here is our relative maximum. It is the highest point of all of those in an open interval right around it. So if I was to open up just sort of hypothetically an interval that would go in that space, this point is the highest point of anything that's inside that interval. And I could even widen that interval a little bit and go out here and do it, and then I could go out here and do it. So because there's any interval that I can open up where there is a specifically highest point like that, we have a relative maximum there. The easy way to sort of interpret a relative maximum is it's higher than all of the points that are right around it. Contrast that with this point over here, which is very clearly our relative minimum. If I look at all of the points that are around it in an open interval, we're decreasing into it and increasing out of it. Therefore, we have a relative minimum. And you should expect there to be a connection between the logic of increasing and decreasing functions and the logic of relative minimums and maximums. If I am an increasing function and I am increasing up and then turning and coming down and turning into a decreasing function, that had to happen somewhere. It had to happen that our direction was switched from an increasing section to a decreasing section, or in the case of a minimum, a decreasing into an increasing. There is no highest number of relative maxima and minima that you could have in a particular graph. There could be an infinite number of relative maximums and an infinite number of relative minimums, and we're going to see some of those functions as we go through this course. It's important to note, though, that both of these are simply relative maximum and minimum, because there are locations in the graph that obviously go above where the maximum is and below where the minimum is. So we're not able to put a label on it that says those are absolutely the highest point and lowest point. We'll look at this graph one more time again. Here we have a relative minimum, and here we have a relative minimum. Again, the direction changes from decreasing to increasing at both of those points, and we have a relative maximum here. If I wrote out those intervals again, that's where I would expect to see the unions happening. Maybe it switches, and in those locations it switches from one to the other. Don't think too hard about this. You're just looking for those peaks and valleys in a function where we see directional change.